Yeah, hello everyone. This is Asin Raju from Chebrodu Engineering College, built the stream of Mechanical Engineering. In the previous class, we have been discussed about the introduction of Mechatronics. In the today's class, we'll be moving on with respect to the elements of that mechatronic system and what are the components existing in the system, how the working scenario will be progressed in the mechatronics unit. In the combination of both mechanical and electronics, the system of offense and the typical elements required for the progressing of entire practical working process in the laboratory as well as in the industrial field will be seeing in the today's class. We are all aware of the basic definition regarding the mechatronics is that it is a synergetic combination of both mechanical and electronic components which are guided in the case of working under the systemic supervision. So systemic supervision in the sense the programmings will be dumped, they will be returned and will be dumped in the microprocessor that will be fed back to the electrical components. That electrical components will be fixing in the mechanical components. Finally, the program that has been written will give the signals as per the periodical basis with the support of these electronic components to the mechanical actuators, indeed to commence the output in a perfect manner. Coming to the elements of this mechatronic system. Initially, what's the system means? It's defined as a black box which has an input and an output. So input will be considering as an a basic source for working, and output is nothing but the result obtained upon get processing based upon the given input. The system is concerned only with the relationship between the input and output and not on the processor going inside the box. So actually this is called in non-support basis of the output cadre. So non-support basis in the sense here the output doesn't matter whether it is exactly correct or not as per the standard results. Whether you have given the input and will be having the standard outputs related to the previous analogy, whether the obtained output has been matched with respect to the existing statistical results or dynamic results, it doesn't matter in some cases, and in some of other cases this output will be scheduled or compared with respect to the standard results. So hence, depending upon these two different strategies, it has been subclassified into two different categories. That is, first one will be calling as an controlling system. So entire this system has been scheduled or composed into two different groups. That is, first one open loop control system, second one it is closed loop control system. And we have already discussed that output will not be related with respect to the standard results. That will be coming under the open loop control system. And the standard values with respect to the output measurement is in the case of this closed loop control system. Here there is an example that is showing here. Input: an electrical power supply has been given to a motor, and hence this motor is being driven with respect to the circular interpolation, nothing but a rotation of that particular motor towards the clockwise direction or towards the counterclockwise direction. That will be depending upon the polarities at the electrical power supply. Hence, the input is an electrical power, output is nothing but the rotation of the actuator, and hence the system is nothing but a motor. Generally, we'll be utilizing this motor in our domestical purpose and in different application point of views also, playing with the toys and in the domestical purpose for filling of an overhead tank for the uses of domestical purpose. So hence, the output doesn't matters here. How much fluid it is being discharged from one place to another place or from a lower altitude to a higher altitude. But work is being progressed. That is an count. So there is no any feedback element required for the activity that is being performed by this system. We will be proceeding furtherly. The different types of elements required in the mechatronic system. Considering the n number of components or elements, that is actuators, different types of actuators to be worked depending upon the given programming, different types of sensors required for sensing the operations that are being progressed, or the feedback element as in sensor that is giving the signals from one systemic device to the another systemic device through a contact type or non-contact type of mode. Thirdly, input signal conditioning on the interfacing. So input signal conditioning in the sense the input power supply, and interfacing in the sense a bus interface system that is nothing but a cable of offense USB or else the wire systems in the electronical basis will be utilized for the perfect input signals or instructions set to be transferred through a wire basis system. Next one is an digital control techniques. So how the given instructions within the processor can be controlled with respect to the digital basis. Digital basis. So here the techniques in the sense we can be using the PLCs and simultaneously the battery references can be utilized. Battery references, PLCs, and Android based systems, etc. can be utilized. And nextly, it is an output signal conditioning and interfacing. Yeah, after completing the process, the actuator rotation or else the translation or else the movements of each and every actions will be con- conditioned and can be interfaced, or translation of one systemic output to the another system as an input that can be interfaced and conditioned at an output signal terminal basis. And whatsoever the output signal processing or interface unit, the work that is being converted from one zone to the another zone or transferring from one zone to the another zone will be monitored digitally or graphically in the display unit. And this display unit may be our CROs or cathode oscilloscopes or LCDs, LEDs, etc. can be utilized. So there is another controlling device that is being interfaced with respect to the output signal monitor to the actuators for commencing the activity. So the basic source here it is to produce a motion, any kind of motion, that is either it may be a translationary motion, that is nothing but the to and fro motion, or else rotatory motion, either it may be in the clockwise or counterclockwise, or revolutory motions, similarly in the clockwise or counterclockwise direction. Whether the instructions, when the instructions has been given from the AC or DC power supply to the sensors carries the signals from the basic source to the interfacing unit. This interfacing unit is nothing but the amplifier that has been connected or connecting circuit input devices. And the signals will be passing on to the final or overall operating controller. Overall operating controller. So whatsoever the terminal process at each and every phase it has been pursuing or processing, that will be displaying in the form of an graphical representations. So that may be of an sinusoidal waves, square waves, or cutoff waves, peaks and valleys generation of different frequency levels can be measured in the case of this display screen. And this overall controller will process the signals from one similar strategy to commence the activity by allocating the signals to the output conditioning or interfacing unit. These will be measured, and this controller will give the signals for the DC motors or stepper motor, or else the sliding actuation systems that are being conducted towards the positive X or positive Y, positive X or negative X, simultaneously positive Y or negative Y, or towards the positive Z or negative Z. So DC motors in the sense is an previously discussing this coordinator basis is nothing but the sliding movements towards to motion and from motion. And whereas considering the DC motors or stepper motors or different types of synchronous motors, this will be happening in the revolutionary concepts, that is clockwise or counterclockwise. So these are the best examples related to the working scenario of elements of mechatronic system. How the input signal is given, how the sensor is being transferred the signal from the basic source, that is nothing but the power source, to the signal conditional or interfacing unit. And this amplifier is being converting its signals from one to another phase. Overall controller will monitor the perfect signals or voltage mode or electrical phase of mode to the output actuator or output controller that is being interfaced. And overall these actions that are being connected to the display unit, and the output signals will be getting transferred to the DC motors or different types of actuators to be worked in an existing way. So, in depthly, what are the actuators means, sensors, input signals, etc. By streamwising, we'll be looking after one by one individually what the actuators mean. So, actuators is nothing but the physical actions that are being done based upon the controlled input signals. So, what are the kinds of actuators existing here? Solenoids, nothing but switching on, off. Next, voice coils, DC motors for generating the RPM, stepper motor for conditional revolutionary basis. We will be utilizing the stepper motors. There is a fixation of theta orientation. Servo motors, continuous revolutionary concepts. And in the case of hydraulics, pneumatics. So hydraulics in the sense using of the fluid offenses for driving purposes, and pneumatics in the sense utilization of the compressed air or gas for driving purposes. So these are the some of the activating elements utilized in the case of this mechatronic system for getting done the desired working process. So indeed to work these different kinds of end effectors or else the actuators, the signals need to be given in the form of an wire connectivity basis or else the non-connectivity basis. So for that particular purpose, we will be utilizing these sensors as a major part. So here there are sensors. Sensor is nothing but a element that is utilized for sending the signals for correct operational strategy. So generation of or circulating the entire input signals to an operating sector, different types of methodologies or modes will be utilized. So those are nothing but the sensors. And let us see what are the best examples existing in the case of sensors. Different types of switches. Switches in the sense switch on position, off position. On position will executes the operational process and off will just halting the positions. Next, the potentiometer increases the voltage capability, that increases the rotation or revolutionary concept of the actuators, or speed incrementing or decrementing or accelerating will be calling as. Next, photoelectric identification of n number of rotations made with respect to an photodiode elements. Digital encoders, yes, optical encoder, digital encoder, magnetic encoders can be utilized for revolutionary or translatory basis of most probably in the case of revolutionary measurement, that is RPM measurements. Strain gauges, there is how much stress that has been acquired within the objects. Next, the thermocouples, this is on temperature basis. So within the climatic conditions or operating parameters, withstand limitations, the temperature is being controlled or not, or varied or not. And accelerometers, increasing of an RPM or decreasing based upon the situations required in the operating sector. So these and all are the types of sensors that has been utilized for different operational processes that are required in industrial sector. And in some cases will be utilized in domestical basis also, even in the automobiles, both in statistical and dynamical motion of an objects. So for this actuators, the sensors is interlinked with each other, and for that, for both actuation of these actuators and the sensors, the input signal conditioning and interfacing is required. So indeed to work in a perfect way, the sensors plays a major important role for giving the signals to an actuators. But the sensors, what the sensors need to be carried. So information carriers, it's okay. What it has to be carried, here it plays a major important role. Input signal conditioning and interfacing. So whatsoever the instructions need to be carried by the sensors to the actuators, here it specifies in the interfacing and conditioning unit. That is discrete circuits, amplifiers, filters, analog to digital converters, and digital to analog converters, or analog to analog converters, and digital to digital converters. So in the form of analog display, if we are given the input, automatically it has to be transferred into the electrical basis also. Even we can consider a best example in the daily basis when we used to give the acceleration by giving the force, by applying the force on the pedal with our leg in the automobile, that is nothing but a car. Indeed, to increase the acceleration, we are applying the pressure physically by our leg on the accelerator, and simultaneously it is being increasing in the resistance that is being circulated to the engine, and engine is being getting given with an higher efficiency of operation generating the highest torque and being driven to the driving wheels, being transferred to the driving wheels, which increases the speed. Here the conditional monitoring plays. So physically we are applying the signal in the form of applying force on the pedal with our leg, which is converting in the ways of RPM. So here the physical force is being converting into an voltage signals by increasing the resistance, and that leads to increasing in the operational sector of the engine, and that engine is being giving the highest efficiency at the output range by consuming the fuel, and that output is being transferred into the torque, and the torque is being transferred to the wheels, driving wheels. So this is the actual scenario. It is an interlinkage between one factor to the another factor. And the other elements are digital control architecture. So how this is controlled with respect to the digital basis. Physical application of inputs, physical operational parameters, it's okay. But here the mechatronic system includes that digital control, that is reducing of an human involvement physically. So here the digital control architecture came into the force. So without human involvement, how the actions will be getting programmed will be existing in these logical designs. That is incorporation of these logical circuits, microcontroller utilization, microprocessors are controlled by these microcontrollers, and the programming is being dumped in the microprocessors, SBCs, and even the PLC system can be utilized, programmable logical controllers, PLC systems, sequencing and timing factors, logic and arithmetic divisions, controlled algorithms, and different communication systems will be utilized indeed to program, and that program will be controlled by the microcontrollers or PLCs. It can be altered, that is, can be rewritable, can change the directional aspects as well, will be transformed for the commencement of activities. Alright, coming to the output signal conditioning and interfacing. So whatsoever the sensor that has been converting the input parameters to the input signal conditioning and interfacing unit, and how the actuators will be utilized, we have been discussed in this particular slide. And moving on to these output signals, initially the conversion of from physical parameter to the electrical to again the physical has been converted by utilizing this analog to digital to analog, such a way. So the operational parameters may be involving in the case of working the digital basis, and hence voltage signals has been converted physical to voltage. So after completion of that particular parameter or working parameter, it has to be again converted into the similar strategy by indicating the entire force from voltage signal to the analog display. That is how much speed that we are moving will be indicating with respect to an analog needle existing in the speedometer. So for that particular purpose, again after completing of this acceleration, the motion need to be displayed in the analog format. For that particular purpose, the output need to be transformed again from digital to analog. And in some cases, digital to digital or digital to analog to analog, etc. And some amplifiers will be utilized. Nothing but physically what you are talking will be amplifying by increasing its resistance or vocal capability or sound that we will be calling it, and dispensing as an output from the amplifiers. PWM, power transistors, power op amps, operational amplifiers, power operational amplifiers. And coming to the graphical representations or graphical displays, these CROs can be utilized There's an actually old process that will be displayed in the sinusoidal display or a square wave form, full wave, or half wave in the format, like that. And simultaneously, the digital form of displays in the form of a number coding digital display, nothing but numbering system, is an updated technology that is displaying both in the LEDs, LCDs, crystal displays, and emitter diode displays, or placed in an advanced technology display units. So measurement. What is meant by measurement? Any physical quantity that need to be operated with respect to the mathematical mode is nothing but the measurement. So measurement, any physical element that need to be examined, the movement, or its physical movement from source position to the destination position, will be monitored, and measuring nothing but giving a particular value of its movement that has been passed by an object is called measurement. So here already what is meant by system, and what are the components of a system, and what are the modes of the system, we have been discussed so far. But what is meant by measurement system? Just for an example to the system, we are considering an example of measurement system. So the measurement system is defined as a black box which is used for making the measurements. So measurements is nothing but the generating of a value for a physical parameter of work. So it has the input as a quantity being measured, and the output as a measured value, right, of that quantity. So nothing but a thermometer, domestically or else in a medical factor that we are utilizing the thermometer. So what is the input for this thermometer? Thermometer that we will be seeing, that is measured in degrees Fahrenheit, or else even degrees centigrades. Thermometers are also existing for in laboratory processes also as well. This input is nothing but the providing of this temperature. So those temperatures which are higher or than the normal atmospheric range of temperatures need to be measured, which cannot be resisted with respect to the human power. And the mercury that has been existing within the glass tube will be raised as per the markings that has been given in the form of an coding, or else the analog identifier, scale representations. The temperature will be given to a thermometer as an input, and this sensor will senses and executes the raising of that particular temperature displayed upon the, or traveling of the particular mercury will be sensed by the sensor, and here the one converter will be utilized, and this, if it has been converted to the digital display, here in the LCD or LED display, it will be indicating with respect to the numeric character. Or else in the case of analog display, the number will be initiating on the scale as an output what physically will be carrying. So hence the temperature is being measured in the scale, that is an analog display. By utilizing the sensor, it is converted from the analog display to the digital display, A to D converter, and in the digital display we will be seeing the numbering representations, how the temperature has been increased or what that particular physical parameter is. That is an example of a measurement system. So what are the elements that are existing in the measurement systems? So measurement system consists of basically three different elements, that is a sensor, signal conditioner, and a display unit. Alright. So here, considering it as a basic example here, a sensor, signal conditioner, and display. Indeed, to work this measurement system, we need to provide the external parameters. External parameters. So, sensor we already discussed regarding this sensor. Sensor is nothing but the physical parametry that is being transferred from the source to an operating sector. So signal condition is nothing but the operating sector. So the sensor is being carried the quantity which is to be measured up to a signal conditioner itself. So operating processor, nothing but the processor. And hence this processor will process the entire activity, or the programming nature will be functioning in the case of the signal conditioner or processor, and will be driving to the display unit. And this display unit, if it has been analog, it will be indicating with respect to the needle fluctuation, or when it has been given to a connectivity to the digital display, then it will be indicating in the display unit. So nothing but here the actuator is given as an input to the sensor. Actuator is nothing but a rotating element, nothing but a motor. We don't know that the motor is being rotating, but with what RPM or what speed it is rotating, that we don't know. That need to be identified. Generally, you will be utilizing the tachometer for measuring the speed or RPM of an actuator. So this actuator has been connected to this sensor. Rotating element is connected to the sensor, and this sensor tachometer internal functioning unit. So this sensor will give the signals to the processor, and this processor will identify the entire functional devices, or how much RPM, with how much RPM it is being rotated. And next the display device will highlight the entire signal processes, and that value will be identified and displayed in the display unit, whether it has been connected to the digital display, or else will be displaying in a fluctuating of that particular inclination, within some inclination of that analog display. This is nothing but the just quantity being measured in the sense. Similar example. So going in depth to this sensor. Sensor is one type of sensor, consists of a transducer which functions is to convert from one form of energy into another form of energy. So this energy is nothing but physical parameter that we have been just seen here. Actuator is nothing but the rotating element. It is a physical parameter rotating. It is being converting from physical mechanical energy to then electrical energy. That is signal condition is electrical energy. So converting of transducer, basically transducer is nothing but transformation of one physical form of energy to the another physical form of energy, or one form of energy to the another form of energy. And basically transducer is a type of sensor. It's a type of sensor. And hence here the sensor itself defines that it consists of a transducer whose function is to convert the one form of energy into the another form of energy. Hence the sensor is nothing but a sensing of a element of measuring system which converts the input quantity to an output quantity which is related to the equivalent factor. So nothing but just we have seen the example that unknown temperature need to be measured and value must be displayed. So the measuring element is nothing but temperature sensor. Thermocouples will be utilizing as a temperature sensors, and input is nothing but the temperature, which is an unknown at an input range, need to be measured by this particular sensor, that is thermocouple. And output is nothing but the EMF. How? In the electrical phase. Electrical phase EMF, electrical parameter. Alright, this is the best example of the sensor. Signal conditioner, what it means. It receives the signal from the sensor and manipulates it into a suitable condition for display. So nothing but internally whatever the functions need to be monitored will be processes in the case of the signal conditioner. And the signal conditioner performs the filtering activity, amplification activity, and other some signal conditionings over the on the sensor output. Here there is a clear cut observation. There is a temperature measurement is nothing but the signal conditional function. There is the object that can be, or a device that can be utilized for this is an amplifier. Input is nothing but the small EMF value which is arrived from the sensor, and output is nothing but the EMF value that is amplified again. And hence moving on to the display system. So display system is nothing but an output sector that is achieved from the signal conditioner by an analog format or else in the digital format. It is nothing but a temporary store such as a recorder or accumulator, also will be calling as an accumulator, also nothing but an temporary device. In the digital phases we will be calling it as an, but in the case of spherical parametry, digital system is a temporary store such as a recorder. Here it clearly specifies the display is nothing but the LEDs or a number on the scale by a pointer movement. So nothing but our analog display will be seeing in our dynamometers also. So for achieving this display, the input is conditional signal, that is from signal conditioner, and output is nothing but the value of that quantity, nothing but the temperature will be displayed on the particular display device. Alright, actually this is a temperature measurement system. This is a sensor, thermocouple. Thermocouple is one of the sensor that is connected to an amplifier, and internally this is a signal conditioner. Our processor we will be calling as a signal conditioner. As a processor, sensor will sense the signals, nothing but unknown temperature at that particular zone, and will be given as a signal to the amplifier, and this amplifier will process the signal and will be, the processed signal will be given to an this analog to digital controller. And here the temperature is physical parameter, that is unseen and unknown. This temperature is given with an voltage signals as an electrical format to the amplifier, and this amplifier stimulates the output to an ADC, that is analog to digital converter, and hence this will be displayed in the output. This output is displayed in the display system, that is nothing but LEDs. If this A to ADC is does not existing, analog to analog in the sense, it will be converted to the dynamometer. It indicates in the physical parameter of storage. Physical parameter. Next one, system control. So it's meant by system control. How the processor is being controlled for a better operational process. And next we'll be seeing in-depth system control, how many types of system controls are existing. A blank which is used to control its output in a preset value box. So clearly identify this, a blank which is used to control its output in a preset value box. So preset in the sense almost the input has been given. So indeed to achieve the value, already preset value, the entire working process need to be performed at that particular system. That's an system control in the sense. So almost the scheduled values or standard values are existing with us, and by giving the input, the processor will process the overall system, and output need to be achieved with respect to the standard value already existing with us. That is nothing but the system control. In such a way, the input parameters or else the processing zone need to be maintained. With reference to the standard value, this output value need to be achieved to us. That is a major parameter need to be identified. Clear? And nothing present, considering a best example, input that is nothing but requiring of temperature. There's an processor will process that, and what temperature, at what temperature it is being existing, the system is being existing will be displayed on the screen. Here, the control system is nothing but the air conditioner unit, will be calling as an AC. Input is nothing but the surrounding temperature. Internally, there will be one temperature, and output is there will be a preset value. Nominally, in the case of this atmosphere, will be having 30, 31, 29 to 31 degrees centigrade of temperature. Internally, if we set the value in the remote, that is to 28, ultimately the hot air will be getting removed by the compressor and will be sent out by converting this air into the water droplets. And this preset value is nothing but the temperature need to be attained that has been set in the remote base physically. And this air conditioner unit will process that particular processor, nothing but the control system, central heating system or central conditional system, what we will be calling as here, and will be equivalent to the preset value. There's a system control. So in this system control, there are two different modes already have been discussed here. That is, one, it is an open loop control system. There will not be existing any feedback for it. Input will be given to it and switch is being on and process will be getting done and output will be achieved. And here the preset values will not be determined with respect to the output. Output, how much the value has been achieved, that achieved value is nothing but as considered as an output in the case of this open loop control system. Hence, here we have been clearly specified that there is no any feedback. Going to the closed loop control system, there isn't feedback to it. Nothing but indeed to exist this preset value in the output display, we need to have this particular closed loop or feedback system. Here see, input reference value need to be identified given to the comparator and controller unit will take care of the particular values and process the entire actions in the form of this correction unit, and entire the operational process will process in the unit and will, before moving on to the output sector, the obtained value after processing in the processor will give as a feedback signal for an measuring with respect to the standard value. The standard values will be existing in the controlling unit, and this comparator or comparison element will compare the obtained value is equivalent to the already existing standard value. If there is any fluctuation plus or minus existing in the comparator unit, depending upon the processing at the output zone, that negatives or positives will be monitored with respect to this in control unit, and that will be corrected by this correction unit and will be processed again. And after achieving that, here will be considered as an inspection process. After achieving the standard parameters, then only it will be moving on to the output cat. That is the case of closed loop control system. Whereas in the previous action, there is no any such kind of feedback elements or comparison element for the better standard value measurements. And here in the closed loop control system, we are having that. And hence here the precision will be very much high. So what are the existing closed loop system elements in the sense? Comparison unit, control unit, correction unit, processor unit, and next measurement device, nothing but then feedback alignment elements. So here we'll be seeing one by one. Comparison element. It compares the reference value to the measured value, and the error will be identified. That error will be compensated by your correct and correction element. So control element, here it is. Control element is nothing but the decides the corrective actions to be taken when an error signal is received. So error signal, when you have been received it will be controlling by a signal operating switch on and off. That is an open or closed systemic zone of operation. And we'll pass the signals to the correction element. Here, this correction element will do favors for getting the output related to the standard relations, and in such a way the working scenario or to the processor it will be passing, so that corrections will be produced, a change in the process to correct or change in the control condition. It also provides the power to carry out the control action, and it is known as the actuator, right? Next one, processing element. So processing element is nothing but What are the existing changes that has been made in the correction unit need to be processed by this element. So that is that controls the process is known as the process element. So room temperature of the house is being controlled when AC preset value has been given, and depending upon that, the additional temperature is being removed by absorbing the air conditioner and letting it out in the form of a droplets. So measurement system. How far this action, that is removing of an heat from a closed system or closed room, need to be commenced. So how far until this measurement system give the equivalent signal to the sensor. That is an input signal. Comparator measures. That is nothing but the feedback alignment. This is measurement element. This is also known as the feedback alignment. This measurement element produces the signal related to the variable condition of a process that is being controlled. So control, what we have been controlled, will be compared with respect to an existing preset value, and that preset value should be equivalent to the measured value, right? And hence this thermocouple gives EMF related to the temperature. Next one, let's see one example. Filling of an water tank. Here just we have seen the air conditioner. Similarly, we'll be seeing as an water controlled example. So controlling variable here, it is an water level in the tank. Water level in the tank need to be controlled. So reference variable initially setting of the float and level position. Comparison element is nothing but the leveler, and error signal is difference between the actual and initial setting of the lever. So domestically we'll be seeing the this particular application. We'll be having the overhead tank upon our floor, and we'll be switching on the motor. And after, how we will be knowing that whether the tank has been filled or not? After completing that, there will be one let out safety valve will be opened, and when the water is being falling down from the higher altitude to the lower, we'll be considering recognizing manually and switching off the power for that particular motor. So there will be a wastage of water over there. So indeed to compensate that particular activity, indeed to save the power for the motor, electrical power, and indeed to decrease the wastage of that particular water, we will be placing a sensor over there. When the motor is being switched on at the low conditioner, when the minimum level of that particular water has been reached in the tank, this sensor will give the signal. Nothing but this level will be identified with this level sensor and will give the signal to an level transmitter, level controller, and next the to the electrical power supply. It will be getting connected to the electrical power supply. Automatically it will be getting switched on, and hence water by utilizing the motor will be filling this particular overhead tank up to what? Up to an this is a minimum temperature range. Up to a maximum temperature range, it has to be filled out. So after reaching the maximum level of the particular water tank, again this level sensor will identify the signal that has been achieved at a maximum level, and will be transmitting that particular level by using this level transmitter, and level controller will give the signal to the motor electrical power supply to be switched off. So hence there is no any involvement here of human beings. So there is no involvement of the human beings. Simultaneously, when the water level in the overhead tanker reaches to a minimum range, automatically this level sensor will senses the signal and transmit that particular signals to the level controller, and controller will initiate the electrical power supply, and hence the motor will be automatically switched on and will fills the water in the water tank. Simultaneously, after reaching the maximum point, same level sensor will give the signals to the level transmitter to the controller, and this controller will give the signals to an electrical motor to be switched off automatically. Right? That is we will be calling as an automatical system zone. So this is the systemic carriers and elements of this mechatronic system. And similarly, we will be seeing the depth of applications in the next class. Thank you.